So on the board here, I've built this very, very simple amplifier. So here we have the decoupling cap on the input again. And we have, let me just draw a dot in there to show that's joined on. We have that feeding into our NPN 3904 transistor. Here's its emitter. Let me label that E for emitter. Here's the collector and here's the base. So that's providing the base current, which is obviously alternating. The transistor is being protected and biased by this 4K7 resistor. And then you'll see there's a feedback network, just like we had on our op amp here with this 470K or 470,000 ohm resistor, feeding back some of that collector output back into the base. This causes the transistor to further amplify the signals. It also helps stabilize it. So out of here, we have a much bigger signal. Just note the two different signal phases here. This is reverse polarity because of the configuration of this transistor. And here we have another decoupling capacitor on the output. So very simple circuit, and I've built it up over here on the breadboard. So here's the 4K7 resistor, here's the 470K resistor, the input capacitor and the output capacitor. And you see that I've connected the emitter to ground as it is here by this yellow lead. And then my positive is supplying this resistor. Here's our input, and I'm just sending it a sine wave from what's called a function generator, which I'll show you in a second. And then these are my oscilloscope probes here, and you can't see this one, it's just out of shot. I'll just move it into shot so you can see it. And they are measuring the input in yellow and the output in blue of the circuit. So here is my function generator, and you can see I'm in the 2K range, 200 to 2K, and I'm setting it about 1 kilohertz, 33 millivolts, so very low amount of voltage, and I'm in sine wave mode, and that's coming out of here. Follow the wire down, we'll see that it's going into the circuit. What I'm getting out from that is this on the oscilloscope. The yellow is the input signal and the blue is the output signal. Now if we look down the bottom here, we'll see that the divisions for the yellow signal are 10 millivolts. So we've got about 1, 2, 3 divisions. So we've got about 30 millivolts, and we know that's right, we're sending it 33 millivolts. Because it's such a small voltage, you can actually see it picking up noise and fluctuation on the screen, see it flashing. And that's getting amplified as well. See these little glitches here, and also my phone will make it glitch too because it's picking up the interference from my phone. But look down here, 2 volts per division on the output. So we've got 1, 2, about 3, so that's 6 volts coming out of this. So it's a simple amplifier, it's got no noise protection or anything at the moment, but it's amplifying. But note that the signal is now 180 degrees out of polarity. Now watch what happens if I push the transistor beyond its limits by turning up the voltage level going into it. Watch the blue signal in particular. The only reason the yellow signal is kept is because it's gone off the top of the screen. But look what's happened to the blue signal, and I'll turn that up quite a lot. Let me give it 200 millivolts instead. That's about there. And then I'll just press this auto button and it will adjust so we can see the output now. So look what's happened to our output signal. It's asymmetrically clipping, and it's because I've driven the transistor beyond what it's capable of doing. So the input signal is still perfectly fine. The output signal is squared off, and the duty cycle is not even in the lower and upper portions. So now causing clipping, and this is at the heart of the circuit we're about to build, the fuzz face. We're going to purposely make the germanium diodes do that in order to get a fuzz sound. So if I now bring this amplitude back down again, going to, at some point around there, stop clipping. I'll take it down to about 20 millivolts, and then I will press this auto button again, and you'll see that it'll go back to what we had at the beginning, hopefully. There we are, with our amplified blue signal and our input being the yellow signal. And you can see now the blue signal, 3 volts peak to peak, yellow signal 20 millivolts peak to peak. So you've got 10 millivolts per division there versus 1 millivolt per division. So this is what we're looking at. So we're now using the transistor as a very simple amplifier. Just to recap on that circuit before we move on. Here it is. So we've built that on the breadboard over here, and we're actually amplifying signals. So we've built another audio circuit, but this time we've been using transistors. So the next part, we're going to start to build the fuzz face. We're going to look at the circuit for that and start to build it on the breadboard and see what fuzz tones we can get out of it.